Welcome everyone to another episode of the SBA show. Today we're joined by Derek Layfield from Durra Panel. For those of us joining us for the first time, my name's Hamish White, one of the founding members of Sustainable Builders Alliance and director of Sanctum Homes, and I'll be your host for this evening. In the spirit of reconciliation, we'd like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to elders past, present, and emerging, and we extend our respects to all Aboriginal and Torres Strait Islander people of today. As I said, today we are joined by Derek Layfield. Derek joined Stramit Industries as a junior cadet in 1979, learning the ropes of sustainable manufacturing before purchasing the company's manufacturing facility and technology rights to their product Stramit board in 1991. For more than 30 years, Derek has continually innovated, re-engineered Durra Panel while continuing to manufacture Durra Panel in regional Victoria from waste wheat straw sourced locally from Australian farmers. Derek is passionate about changing the way the world thinks about building. By speaking transparently about Durra Panel's cradle-to-cradle life cycle, he hopes to educate the natural carbon cycle, highlight greenwashing within the building industry, and encourage people to choose truly sustainable building materials. Derek's enthusiasm for sustainability and responsible manufacturing has led to Durra Panel being installed in major projects such as airports, schools, stadiums, industrial facilities, data centres, offices and homes across Australia and the world. Today, this webinar is brought to you by one of our fantastic platinum sponsors, Royal Windows and Doors. Today, there's going to be a short presentation. So Derek's going to talk to us about what Durra Panel is. And then we're going to have plenty of time for some Q&As after. We already have a heap of questions that have been emailed through. But if you did want to pop some in the chat, that would be amazing. Derek, I'm going to throw it over to you, mate. So can you tell us all about Durra Panel?
Not a problem, and thank you very much for the invitation, Hamish. I think there's only one thing missing from this first slide because it says from paddock to panel. What it should say is from paddock to panel at the end of useful life. It can be returned back to the paddock because it's 100% biodegradable to help them grow more food, which is that cradle-to-cradle life cycle, which is, I think, quite unique. Look, at first slide we've got, look, what is Durra Panel? I hope this works. Yeah, beautiful. In essence, Durra Panel is 96% straw, a waste byproduct of farming. The other 4% is made up of a recycled kraft liner, which encapsulates the panel core with a PVA glue line sitting between the core and the paper. That's all there is in the panel. There's nothing else. So it's a completely natural building material. Click it if you can. Clean air, food, they're essential to life on Earth without stating the obvious to all of it. Every year, it's one of the things we need to think about is every year, the world's total transport emissions are being sequestered by 5 major food crops. Rice, wheat, cereal, coconut, and corn crops. The waste material from that crop is generally burned after harvest, re-emitting all of that stored carbon back into the Earth's atmosphere. Think about that for a minute, okay? That's a fact. That's how it is. It's an enormous fact. The World Health Organization has estimated that every year there's 7 million people that are killed as a result of inhaling particulate carbon released through the process of crop burning. Okay, 7 million people. Of that, 650,000 are kids, children. These are big numbers. These are huge issues. Some of them are almost too big for countries to address and try to figure out what they're going to do to stop this practice. It's a massive thing. I was in India last November, and we're looking at putting a technology transfer project up into the Punjab region using paddy straw. While I was there, through their government department, I was told that the life expectancy in Delhi has been reduced by 10 years. 10 years as a direct result of crop burning after harvest. It's a huge issue. It's a massive issue. It's right next to us on our shores, Malaysia, India, Cambodia, Vietnam, all these countries. They've all got this issue going on, and they're all at the same time trying to figure out how they're going to get to net zero. They've got no idea how to get there. And this opportunity is sitting there in front of them. Carbon capture and storage. Rather than burning that raw material with regard to rice or wheat, we can harvest the waste. Every kilogram of Durra Panel weighs around nominal 18.5 kilos a square metre. Now, of that raw material that we're used in our panel, that raw material has sequestered 31 kilograms of carbon dioxide out of the Earth's atmosphere over its growing cycle. 31 kilos. Of that sequestration, 8.5 kilograms of that is stored as direct carbon in our panel core. Straight black carbon in our panel core, 8.5 kilograms a square metre. That's highly significant. We can click that one probably. To explain a bit about the manufacturing process. Now, we're located, as Amy said, in the middle of the wheat belt, Victoria, as close as we can to the source of our raw material, so that we can keep our emissions down to a minimum with respect to transportation, et cetera, et cetera. The product is made through a unique, dry, chemical-free, dry extrusion process. There's no additives. There's no binders. There is nothing added during this process to form the panel core. Our technology is working with nature, what's around us. Straw, rice and wheat straw, has a natural polymer lignin. What we're doing is engineering that during our process by applying heat and pressure to get the straw to give up the lignin to help fuse the core together. So there's no water, no gas, no chemicals, no nothing. There's zero toxic waste to deal with. Straw, like we get fines from our process, that's suitable for putting on gardens and things like that to helping to grow more food. We produce at a rate of 100 square metres per hour, which is fairly significant production rate. 100 square metres an hour. And out of every tonne of raw material, every tonne of straw, we're getting around 50, 52 square metres of finished product, Durra Panel, which is a pretty good conversion ratio. Probably that next slide there. Now, you gave a good bit of the history there, Hamish, just to expand a little. At the end of the Second World War, building materials were in short supply, and that's where the idea came from originally, born of necessity, out of having to do something to provide shelter. And really a genius idea. What can we do with biomass? Hey, it's used, it helps, it stands up in the field. What can we do to it? Okay, we compress it. We can make a loosely compacted panel out of it. Okay, great idea. That idea was then taken to the world, and there were licenses given, and there was a lot of purchased, and a license went to the UK, and a license came to Australia, and it was known as Strammett board. It's been in continuous production in Australia since it was first introduced in the 50s. So it's got a long, tried, proven history, track record. I mean, it's, people wouldn't think about it, but Tullamarine Airport, when it was first built, was all Strammett board, Strammett steel sections. The whole airport was made of that product. And it's still as good today as it was then in the Qantas Lounge, in the departure area, if you look up. It's also over all other airports around the countryside, generally speaking. But as I say, it's got a long, tried, tested, proven track record. Click that. The product it's an interesting material. It doesn't have too much mass to be a true thermal mass product, but it's got sufficient mass to do a lot of good things. Why we're in airports is because we're very good at low frequency noise control. That's just a natural characteristic of the product. It's a combination of the matrix of the panel core, made a lot of little air pockets within that matrix, and the fibre itself and the panel density. The panel is so densely compacted. Like we're talking about 60 tonnes per square inch across our workface. So we're talking huge pressures when we're extruding this product to get it to do what it does and release its lignin. Now, when you do a fire test on this product, there's no fire retardants added either, by the way. There's nothing like that. It's just basically craft liner, screw, and that's it. When you apply like an oxyacetylene torch to it, what will happen is the paper facing the craft liner will burn away and char away. You take the flame away, the product will self-extinguish. The carbonising action of the core is naturally resistant to fire. It's a very big thing to understand. It's so important. We talk about the thermal insulating properties of the panel. Okay, back in 1979, the whole industry talked about thermal conductivity through building envelopes. Glass wool insulation was just starting to come onto the market around the mid-late 70s, early 80s. And that's where R rating sort of came to be. Or the most important thing in everything is an R value. No, it's not. It's not in Europe. See, it's all about thermal conductivity. It's a K value. It's how long it takes heat to transfer from one side of that panel to get through to the other side. And it's a physical characteristic of any type of material. It's a K value. Now, Durra Panel has a K value of 0.081 watts per metre K. That is exceptionally low to those of you out there who are technically minded. You can have that oxyacetylene torch on one side of the panel. You can have your hand on the other side. And I know Hamish has felt this when he was up at our factory in real life as a demonstration. You don't feel any heat transfer through there. You don't feel that. Like, you start to feel it for about, well, what would it be, 15 minutes, 30 minutes. There's hardly any increase in the heat from one side to the other. So, a very important characteristic, especially building in bushfire prone areas. I think it's, we've tested recently, we've just done some testing to AS, 3959. Some work that was done on that panel by RMIT University. Now that's like, I think, about 1200 degrees C for 2 hours on the product sample, which was a great test outcome. Modular installation. Okay, we make our panel to order, so we're an extrusion, so you can have the panel any length that you want. So we're minimising our waste. We're modular in nature. We work to basically a 1200 millimetre building grid. Because you can walk on the panel, especially when you're doing skillion roofs and things like that in residential housing, is what we used to do all through the sandbelt before gable trusses came into fashion. The whole of the sandbelt in Victoria, skillion roofs back in the times of merchant builders, etc. They'd be putting Oregon beams there, putting Strammett board over the top, timber batten, building paper and metal deck roof. And that was the industry standard before truss industry took off. Probably flick that now, Stevie. How to use Dura Panel? Well, you can make your building pretty much. You can make a box out of it of Dura Panel. It can be walls, ceilings. It can be included in a floor subframe. So stop losing heat if you're building in an elevated area. The Dura Panel can be used. It's a non-load bearing, but it's self-supporting. It can be fitted back to framework, typical construction. I think this image is clear enough. But you can use a single layer if you're doing internal dividing walls up to a height of 2.4 metres, self-supporting. You're going to go up higher than that. The only problem is you need to go to 2 panels to try and get a bit extra width in your wall to make it stiffer. You know, the people will come in there and their expectation is it'll be as stiff as a stud wall. It's going to be nominal 115 millimetres thick. So they come up and press it. So we need to be mindful of that. The expectation is that, hold on, that wall is not as stiff as a plasterboard wall. Okay, if we put 2 panels together at 3 metres, yes, it's stiffer than a plasterboard wall. If we've got to put services in the wall, okay, we'll create a cavity, separate the panels. You run all your electrical, your plumbing, all of those services, etc. Project applications, I mean, when we do the math on it, there's probably over 17 to 18 million square metres of Dura Panel that's been supplied, installed all over Australia. Pretty much every airport in the country has Dura Panel, or at the time, Stramit roof ceiling systems over it. Brisbane Domestic Terminal, you look at that, all up there, all Dura Panel roof ceiling systems. All the stadiums in Australia, we get a call for those, because of the acoustic properties. Schools are starting to come to the product because they get concerned about the off-gassing of materials that you're putting into, buildings that are going to house young children. In this day and age, I've never seen so many issues related to allergens. What are we doing with kids with, putting them into, foam boxes that are off-gassing, things that are stuck together with formaldehydes, be it urea, formaldehyde, phenyl, isocyanurate resins, all of these things, okay? It's all about the lesser of two evils in our buildings, a lot of these considerations that are being made. So the more we can do with the kids to give them a zero VOC emission environment, the better we can. And Dura Panel can go a long way to supporting that way of building. Defence, great client. They've used us all through the hangars for the Joint Strike Fighter, industrial, residential. I don't want to bang on too much about that, but we've done all the Dockland sound stages and studios. We did all the Warner Brothers ones on the Gold Coast. All of the buildings down at the State Tennis Centre, the Margaret Court Arena. They're all applications of Dura Panel and Dura Steel sections of the building system. The product can be used on its own, or can be combined with other elements to form complete construction systems, data centres, all those things we've had great success with over the years, albeit more for straight practical reasons historically, rather than anything to do with sustainability. Only now are we starting to see some really serious inroads in that regard. So look, thanks, Hamish. I think I really would welcome questions, and hopefully we can provide answers, because I think that's one of the best ways to have discussions for these sorts of materials. But I guess in conclusion, I could say that like Dura Panel is like a product from the future that's been here for 70 years. For want of a better way of looking at it, it was ahead of its time. It was ahead of the curve. But here it is now, and we're looking at it and we're going, Jesus, that's not a bad idea. At the end of this material's life, it doesn't have to go to landfill. It's not going to get into the waterways and get into the food chain and start poisoning people. This material can be returned to the earth. It'll help grow more food. It's 100% biodegradable. So, it's great to have the opportunity to talk to you about it, and at least, I think, let people start to imagine what they could do with it and take it from there.
it blows me away that we're not seeing it more in a residential context. Like in your opinion or in your experience, are you finding it that it's getting more applied in like commercial applications rather than into, I guess, residential applications? And if so, why do you think that is?
Well, look, historically, it was in residential applications going back in the 70s and 80s. Some of these houses now, they're heritage listed. Some of the ones that have been done by Peter McIntyre down in Beaumaris, the Robin Boyd House, and some of these places, they're all Dura Panel ceilings, Dura Panel walls, ceramic board, compressed straw board walls and ceilings. And they're as good as the day that they were put in there. I think it's just this mentality. It's a mentality thing. I think people are now coming because we're seeing more and more organic inbound inquiries now. I think word is spreading about it. And the fact that I think over COVID, people had a bit of time to think about stuff and consider more the spaces that they were living in. And biophilia is being talked about more. I mean, we're all natural beings. We like to think we're above nature, beyond nature. We're not. You do the wrong thing by nature. Nature will soon sort us out. We've got to be mindful of what we do, how we do it. At the end of the day, we just got to stop cutting down trees. Let trees do what they're meant there for in reality. We should be looking at other things like sugarcane, bagasse, all of these things, try to make paper out of these waste materials rather than chopping trees down. It's just dumb, dopey. We've got to look after, preserve biodiversity. We're clearing all these blocks of land, where there was one house on it originally, and now we're trying to squeeze 3 out. Where do we think all of the insect life's going to go? Where do we think everything's going to go? It's madness. It really is. So I don't have the solution for it, but I think this is what's driving people to think I want to build with natural materials if I can, because I know it's the right thing to do.
I think we're at a time and a place, and you brought up COVID just before. Like, I know in our business we definitely saw an uptick of interest in high performance and passive house, particularly when down here in Melbourne, where we spent a lot of time in our home, and we realised that our homes are shit. They're cold, they're hot, they're really poorly ventilated. I know I'm hearing stories from clients of ours that who are now clients of ours. And during COVID, they're noticing mold build up everywhere just because there's more moisture, more condensation within the building with really poor ventilation. It probably is a nice little segue into understanding, I guess, if we're thinking about a Dura panel in a wall build up, like what is the permeability of that wall assembly if we're comparing it to like a plaster wall? Like, is moisture able to pass through that if we're then wrapping our walls externally really well?
Yep. Well, the Dura panel is vapor permeable. It will breathe. I mean, it's all natural because we don't have a resin binder in the panel. It will slowly reach the moisture content of what's around it. It's why it behaves well in areas of high humidity. You've got to keep water off it. I mean, it's a cellulose-based material. If you have instances with it getting wet during construction, well, you've got to keep it dry, like we would with plywood and other building materials. You do things like that, or if you're going to use it there, put an undercoat on it. Seal it up, reasonably timely manner. Just basic stuff. It's just normal tradesman practice.
It probably leads into another question I've got here too, and I think you've already answered the question. But Dura panel, can it be used externally, or is it more of just an internal product? Historically it was used externally. There's no reason why you cannot put Dura panel on the outside of a steel or it's great with a steel frame. It's just going to stop all the heat loss that flows through your frame. Yeah.
But it was used with a cementitious render on the outside over chicken wire. It produced a great outcome.
And is that using the paper, or did you have a different like surface on the other side?
No, just a straight craft line of paper with an undercoat on it.
Yep.
An undercoat on it. Then nailed chicken wire to the outside, in essence. So you keep the chicken wire off the substrate. Then about 25 millimeters of sand cement line render and paint it.
So it's not too different than like how we would apply it to like wood fiber board or a hemp block
It's
or something like
it's
that.
all cellulose, Hamish.
Yep.
It's cellulose.
Yep.
Yeah.
And I think you did touch on it during your presentation, but can you maybe just give the listeners a little bit more of an understanding of how you actually put the board together? Now, I've done a little bit of research on it, so I actually know the answer to it. But how does it all hold together? What are the binders that hold that panel together?
Lignin. It's a stuff that holds trees up in nature. I mean, I don't know if you can see that or not. I'm not sure, but this straw fibre, you can see that. Okay, it's quite stiff. You know, it's quite strong. Now, what's giving that fibre its strength is lignin, hemicellulose in a matrix which is formed through photosynthesis. We're extracting that lignin during our extrusion by, as I said, applying around 60 tonnes per square inch across our workface. These are big pressures we're talking about here. Massive pressures. When it goes wrong, it's a mess at the factory. I don't think we had a problem when you were there, but occasionally we do have a bit of a problem. Anyway, straw goes everywhere. Yeah, but it's huge pressure. Now, by applying, we operate at about 200 degrees C. Now, it's like, you know, pasteurization's at 60 degrees C. 200 degrees C, you know, it's just like a kill zone for anything that, like, if molds or whatever else is going to be in that raw material if it's a bit dirty going in. So all of those things are killed off. So it's heat, pressure. You've got to have a bit of moisture content, the water content naturally occurring in the fibre. So we don't want the fibre sitting there at around about 1 degree moisture content. We've got a specification that we give to the straw contractors, and we take the fibre in it between preferably no less than 4% and no more than around 12%. Otherwise we're buying water. So those are around, that's about the moisture content. Now there's steam produced while we're doing this. We're operating between massive heated platens as we're forming that panel core through the extrusion. So while it's being cooked, for want of a better word, in a big oven, but it's constantly moving through. So that's what's fusing the panel core together. There's also some engineering, which I think is quite clever, which we undertook probably since I took it on in '91, to redesign the matrix of how the straw sits in the panel core, because the panel actually spans across its width. It's very strong. That's why you can walk on it if you support the edges. A panel that's nominal 1.2 by 2.4 metres will support a uniformly distributed load of nearly 2 tonnes.
Wow.
Right? Without catastrophic failure. It'd take a point load, okay, of around about 700 kilos, a point load on a 100 millimetre disc.
700 kilos, point load.
700 kilos on a point load.
Wow.
Now what breaks? Because the panel behaves like a stressed skin material. Remember, we've got a laminate of paper on the bottom, we've got a laminate of paper on the top, and we've got a straw core in the middle. So it behaves like a stressed skin material, like almost like an structurally insulated panel in how it behaves. What happens when we put the point load on it, what fails is the bottom paper facing. It goes bang, basically like an explosion with the force. But the interesting thing is, even once that bottom facing has gone, you can still walk on that panel. It's completely safe to do so. It's a local failure around the pressure point being applied by the point load. because this panel spans laterally across its width. When we put the panel into a walkable ceiling grid, which we do a lot of, it's one of our major commercial product ventures, we export these walkable ceilings all over the world. They're big 20,000 square metre ones, they're massive. And that's Durra Panel sitting between Dura steel sections. Strength is always governed by deflection of the supporting steel grid, not the Durra Panel, which is quite amazing, I think.
I'm actually blown away by this product, to be honest with you. I want to dive into a little bit about there's a few questions here about fire rating. Now, I know you. Can you just tell us a little bit what happens when you actually put a torch on it? And then I've got a few follow-up questions about bushfire rating areas, and then whether or not we can use them as fire rated walls. So maybe just tell us a little bit about what happens when you put that oxy torch on there. So what happens with and why doesn't it like go up in flames?
Well, people look at it and seeing's believing, and I know you've seen it. But what happens? The panel is so densely compressed. You need, to support combustion, you need oxygen. If you haven't got a ready flow oxygen, your combustion you won't burn, or you will char away very slowly. There's two very different things between charring and burning. And this whole thing about combustibility as well. Technically, everything's combustible to start with. I won't get into the NCC yet, but I'm happy to get involved with that. But you can hold it, the temperature on an oxyacetylene torch at the tips around 3,000 degrees C. You can hold that on the panel. And all that will happen is the paper will char off. If I take the torch away, the panel will self-extinguish. I'll put the torch back, it'll just glow red hot. The carbon core will glow red hot because that's what it becomes. It becomes a core of carbon, and it very slowly, under that 3,000 degrees, will slowly give way. And that's where I was talking very earlier about, what was it, we did that testing, AS 3959. And that's 1,200 degrees for 2 hours. And that's for building in bushfire prone areas. Now, we're working on that one with RMIT University, Dr. Kate Meehan. And Kate, she's been on the combustible cladding task force. She headed that up in Victoria. And she's identified our material because of its excellent fire resistant qualities. And the fact, which I probably should have mentioned earlier, because we don't have any toxins when we're trying to burn it in that demonstration, there's no acrid black smoke. One of the silent killers in any bushfire, especially if you're building with petrochemical-based materials, is the toxic gases that are given up by that panel core. And it can be a disaster. It can be dreadful. Every time I see something that's gone up in smoke, okay, that's an SIP job going up. It's the cladding, it's the core material, petrochemical based. You get a 75 mil thick petrochemical based panel, metal skin both sides. Well, black acrid smoke when you do it. Polystyrene foam, one of the worst materials I've seen. It's horrible stuff. It's like cladding. I mean, it does its thing. I get that, but Jesus, it's roughly the equivalent of 5 kilograms of petrol per square metre when you work it out. Is that what we want to live in? I don't know.
I mean, I've got a bunch of questions here, but I want to ask a question for myself. So if we're talking about a BAL 40, because we operate in a bushfire zone here in Warrandyte, and I know we've got a couple of projects coming up which have got a high BAL rating. Could you theoretically get your timber frame, put 50 mil of the Dura panel on the outside, which is obviously going to give us an R value of 0.62, if in our terms. And then put lime render on the outside of it. Is that going to give us a BAL 40 compliant wall system? And does that sit under NCC, or are we going to get some performance solution based on it?
I'd say a performance-based solution. See, what will happen? The paper will char off. The paper's going to char off, and then you're going to be left with the panel. It will slowly go black, 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 black. I can tell you, watch this space at the moment, because I know that you follow what Joost Bakker's been doing, what it's about, etc.
So yeah.
Well, Joost is pushing forward with testing with CSIRO at the moment, and he will be having Durra Panel on the outside, doing the full-scale test up in Sydney. I think it's happening next week or something like that. And it's got Durra Panel on the outside of the house, and then it's got a hemp board that's straight over the Durra Panel, and that's the external.
Could you talking about before of applying that sort of 20 mil render on it? Would you need the mag board or hemp board or even FC sheet on the outside of that if you're just going to render over the top of it?
Well, practically speaking, no, you would not. This is something that we're going to push forward with testing. I mean, this is the way forward, and this is what we've been doing with Dr. Kate Noonan. This will be coming through, but it's got to be tested properly. But number one, we know we get durability out of Durra Panel with a cement render on the outside. Now, the cement render on the outside in bushfire, the way the bushfire works, it goes over the house pretty quickly in that respect. But it's a good build-up of materials, Hamish. It's a perfect build-up of materials. Durra Panel.
Yes, the thing that immediately comes to mind, if we're putting a cement render on the outside of it, we lose that breathability of that wall assembly. So yes. How does that moisture then move through that wall assembly? So I guess my question is, if we use a line render, similar to what we do on a hempcrete house, is that still going to give us the same performance if we did a cementitious render on the outside?
Look, the short answer would be we have not tried it.
Love to know the answer for that.
I don't have the answer for it, but I tell you what, we've always been known for having a go at these things. So it's a good idea. Why wouldn't you?
I think, and I just know the space that we're operating with, and I know I've kind of hijacked everybody else's questions here. For people, I do apologise, but I think if you can nail that with a 50 mil panel on the outside, with your craft paper, and then 20-30 mil of line renderer, like, to me that is an amazing wall assembly, because then you've got 90 mil of high density R2.7 insulation, and then we'll put our air tightness membranes on the inside. And if I'm thinking from a passive house point of view, that's a ripper wall assembly in a bushfire area.
Yeah. Well, I think it would be very robust. That's my practical brain going. I can't see a reason why you wouldn't. It's got a good keying substrate. You'd need to have an expanded mesh or something sitting on the Durra Panel to let it key into properly. But that's more of an engineering thing, which I'm sure we can work through that one.
I know Brian Guinan, one of the other directors, he just put a comment here saying, I so want this to work with line render. And I knew he would get excited about that one. Because
you tell him we can happy to do some samples up. We can have a look at them. And we're more than capable of doing some demonstration testing before we get to pilot scale testing. But I can't see why it wouldn't.
And I know we talked about this offline before we chatted, but it would be great to get an SBA tour through your factory of people coming along and having a look at all of this in real life, because
we welcome that. We've historically we had I took umbrage at the fact that we had to spend a whole lot of money with these people to just prove the fact that we're a sustainable building material. Anyway, we're on the bandwagon. We've now got an EPD out there for people, so they get their EPD. Yes, we don't have any chemicals in there. It's all been verified by third party.
Yeah. And you know what? There is there's a couple of questions here about EPPs. So,
it's out there now.
It's awesome. That's unreal. Just getting back to the fire rating stuff, could you use it as a party wall partition between two units in a residential application?
We did AS 1530.4, one of the old tests that we did years ago. 50 millimeters, I think it was 50 mil thick Durra Panel, and we had I think 13mm plasterboard on either side of it. Okay, that was the 1530.4. That went 2 hours.
Yeah, right. Okay.
Okay, doing that straight up.
So you would still need the 13mm fly rated board in between the two panels.
As a party wall, 2 hour, yeah, it would. I think we'd have to test it to that. But if we know it works like that, I mean, the Dura Panel is stopping, remember, the radiant heat transfer, which is and stopping the fire penetrating through the wall. What the plasterboard's doing.
And then you've got the acoustics, and then you've got the R values.
Exactly.
And, yeah, like you've got all the, like, it's tick, 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 tick.
Yeah, well, the weakness in any of your testing criteria is the fact that we've got to fill a big opening at roughly 3 meters by 3 meters. It's a really hostile test. The weakness is always the panel-to-panel joint in any of the testing that you do.
Yeah.
So it's to come up with the way to deal with an effective panel-to-panel joint, and that's what the layer of plasterboard did when we had that 2 hour test.
Right. Okay. Yeah, I get you.
Yeah.
Is that right behind you there, Derek? Is that a join in a Dura panel there, or is that?
Unfortunately, it's not. Well, it should be, but it's a precast concrete slab.
Okay. All right. Well, we'll move on. We'll move on. Hey, so a couple of other questions here I want to get to. So, what about vermin? I'm sure mice would love to get into that, and termites as well.
Well, we did termite testing, so termites aren't attracted to it. It's not, because it's not a food source. The only time that we really have trouble with any vermin issues is if people cut the panel and they don't end seal it. They don't, and vermin don't tend to eat it, but they'll look at the fibre and try and pull bits of fibre out, to take away and do something with, But the only time we have an issue like that is in regard to not dealing with the panel how it's meant to be dealt with. Most of probably 99% of the time, in my experience.
It comes down to proper detailing of when you're making cuts and stuff like that. So nothing out of the ordinary with what you'd normally do with any wall system.
Well, at the end of the day, if it was, it didn't work, that was on the panel. It's been continuous productions for 70 years, Amy. So, I mean, we export too, as I say, through, and our products are ending up in, Indonesia, Greece. Big 20,000 square metre ceiling systems with Dura Panel that you're walking on and things like that. We don't have any track record with respect to issues with regard to attack by termites and things like that in other countries and bits and pieces, or issues going through the high humidity.
Just getting back to cutting it, when you do cut it, how are you then treating the edges once they're cut, and then joining them? Are you sealing the ends with a tape?
Yeah, we're using it. We've got it's a non-paperback, so it's a straight reinforced aluminium foil type tape that you might see it in in the insulation industry. Actually, Steve's here and he's got a piece of tape. And a panel, it's magically appeared.
Here's one you prepared earlier. Love it. Look at that. So my passive house brain and my sort of moisture movement brain.
Yep.
What happens? Is that going to create some condensation in behind that, risk of condensation molding behind that aluminium, because it's not actually allowing any vapor to move through?
Well, that would be an edge to edge cut, wouldn't it?
Yeah, edge to edge. So it's probably less of an issue, isn't it?
Yeah. It's like if you're cutting a panel, say to width to fit, fit your wall.
And just out of curiosity, is that so? It's mandatory that you would seal that edge.
You could also seal it with a paper tape.
Yeah.
The reason we went with the aluminium reinforced aluminium tape was because quite often we're doing big commercial industrial projects where okay, the panel might get wet during construction, and might be out there for a couple of days getting wet. So the weakness is in the cut end of the panel. So that's why we use a reinforced aluminium tape mainly for external applications. If the product's not going to get wet or something like that, you just use a paper tape. It's fine. Historically, that's all that was ever used during the scrum days with the product. That was just used like a masking tape to seal the panel. That was all they ever used.
I'm laughing because Brian's just popped up a comment here saying we should seal it with Pro Climbers X Dura tape, which is exactly what came to my mind before. But I know he's also a Pro Climber rep, so maybe let's move past that.
Yeah, sure.
But I got a ton of questions here, and I'm conscious of your time. Like, if we're putting on a couple of questions. If we're putting on an internal surface, how am I going to find a stud? If I want to hang a picture or something on there, like, do I need to find a stud, or can I just screw straight into the panel?
The beauty is you don't need to worry about that. You can hang whatever you want anywhere off that panel. You can put your tally off. You can put your big LED TV. You screw fix it straight into your Dura panel. That'll be fine.
All right. And then when I'm looking at it on the inside,
yeah.
Obviously we're all trained and accustomed to having like a plaster finish on the inside. So what's the expectation of that finish on the inside, particularly around that joint? Are we express joining that? Are we taping it and plastering over it? Like, how's the finish of it?
We encourage people to put a flexible sealant, like a neutral cure, non-water based, between a panel to panel joint when they butt together. But the issue that you have, I mean, you can tape it and seal it. You could do that. I mean, if you wanted to, you could skim coat the whole wall. That was a standard thing that was done for years and years and years. That's not an issue. But if you just plaster tape the joint on its own, and you get a critical light on it, then you start to see, as soon as you start to introduce that plaster thing into it, then you got two different mediums. Then you get a critical light on the wall, and it'll look different. The surface finish of the Dura panel, because we're working at such high pressure, like I say, at about that 60 tonnes a square inch across the workplace, it's produced through a reciprocating ramp and pushes it through. And it's not dead flat like plasterboard. It's a very slight ripple through it. I mean, it's a natural material. So if you plaster one bit, a strip of it, and then you put a critical light, a glancing light across it, then you tend to look at the two mediums and your brain goes a bit, what's going on there? So, my thing is it's best to treat the surface with things that are sympathetic to what the panel's about. I mean, historically, it was just wallpaper. People just wallpaper straight over. Get rid of your joint, don't see anything. Put a wallpaper on.
I'm imagining you could put a timber strapping on there or something just to celebrate
celebrate the joint, express it.
Yeah.
It could become almost an architectural feature, which would all blend into ceilings, walls, whatever you're doing.
I'd love to put it on a wall and then throw a thermal imaging camera on there. I think just the density of that panel would look amazing through a thermal imaging camera. I think I'm excited to use this, to be honest with you, and I'd love to nail that external application, because if we could,
you got me going, Hamish. Now I thought of that idea.
Knowing again, I know Brian's got a hempcrete house coming up. We've done a hempcrete house as well, which required lime render on it. I think if we can nail that and get someone to write a performance solution on it, like that's and I can't understand why it wouldn't happen, given you can put like a Stako wood fibre board externally and render it. I can't see why it'd be any different.
It would be. It's cellulose.
Yeah,
so it's just cellulose. Yeah, we're just engineering cellulose. That's what we're doing.
Can we use it in a bathroom?
Yeah, you can use it in the bathroom. Yeah, fine. I mean, remember, the panel's not sitting on the floor. The panel's sitting on like a timber plate or track that sits on the floor. Then the panel sits on that. Okay.
Yeah.
That's an important thing, which sorry, I didn't clarify that. But there are details on our website with respect to, like, you know, how you do these things, installation details.
Well, that's when you're using it as like a partition wall system internally. Yeah.
Correct.
Yeah.
Yeah.
Cool.
Yeah. I mean, if you're going to tile under the panel, I'd probably put some cement sheet on the wall, you know, so you're losing any impact or potential impact between any panel to panel joint, any movement you might be getting in your house. So I'd probably put a piece of cement sheet across and tile onto the cement, you know, fix the cement sheet back to the panel and tile onto the cement sheet.
But if we had it in a bathroom, say out of the shower area, so out of the shower room, but it was within that bathroom area, you wouldn't have any issues with, you know, the panel taking on the moisture and it being an issue with mold or anything like that, because it allows in fact, as you said before, it's quite good in high humidity.
Yeah, yeah. I think it's more a fact of what you're putting on your finishes. You know, it's more about the paint detail and things like that.
We just had a comment here saying it could. We had a comment here saying it could be rendered with micro cement on top of it.
Yeah, why not?
Yeah, well, yeah, why not? Why not? We have to solve that problem about that external render, though. I think that's.
I'm with you on that. I'm with you. We'll get on to that one.
Yeah, let's get on to it. Now, I'm going to ask a couple more questions, Derek, and then I'm probably going to wrap it up.
Yep.
Where do we buy it from, and how much does it cost? How much is a piece of string?
$39 a square meter for the S50 Durra Panel natural finish. Just go to our website, come around and see us, phone us, call us, whatever.
And you ship Australia wide and internationally.
Yeah, ship Australia wide.
Yep. And actually, this is probably a good question. It's obviously a straw product, like the waste product. Are you getting that like within a particular radius of where your factory is, or is it coming from all over Australia?
No, we've got to keep that within a 60. Our factory is located in Bendigo, Victoria, which is in the heart of the wheat belt in Victoria. So our raw materials are coming generally within a 60-kilometre radius of our factory.
Amazing. Talk about sustainability. Well, you know, I'm super excited to, you know, we'll chat offline about organising a little bit of we'll get a bus together from Melbourne and we'll fill it and we'll come up and see you. And we've actually got some more interest here from people about the external render. So I think that could be
we'll have a bit of lime cement. We'll have that lime render ready to go, Hamish, for when you've organised this tour. Give us a
absolutely. Let's crack that, because I reckon that's a game changer. Derek, thank you so much for joining us today. Super informative. Like I'm really excited about this product. I know it's been around for eons and eons, but I feel like we're at a moment in time where these kind of products are just going to exponentially become more popular as people.
Well, people are getting it, Hamish. They're getting it finally. You know, it's taken a while. I'm just lucky to still be here myself now to see it. So.
Well, before you go anywhere, mate, let's crack that lime render thing. A massive thank you to our sponsor, Roll Up Windows. For everyone listening, we obviously put a podcast out as well. It's called the Sustainable Builders Yak. Simon and Brian chat about Prefab Future House with Peter Satry Architects. That's episode 26. You can listen to that on Spotify. If you haven't already checked it out, jump on our YouTube channel and SBA website. We're actually have started to roll out some little mini-sodes. So little shorter, bite-sized bits of content that we're not going live with. We're pre-recording them and popping them on our website. We've got one up there from one of our other sponsors, Vapor Seal, talking about their clicking system. It was the first one, so be gentle and nice with your feedback on it. I thought it went pretty well. But we've actually got the guys from Respira Built coming on to talk about their hempcrete block in a couple of weeks, which I'm really super excited about. And I've just lined up another couple of really cool guests. And this is going to be something that we're going to be talking about. This is actually a manufactured log of timber, which uses little peels of waste trees, which would typically just get burnt. And then uses nanotechnology, which actually binds this together, which mimics lignin. So keep a look out for that one, Derek. I think you'd be quite interested in that.
I love that. I'll be watching that, Hamish.
Absolutely. Next month, we're going to be joined by Samuel Wines, who actually runs a lab called CoLabs, and their whole lab is focused on bio products. Sam is going to come on and talk about like the future of building products, which are all going to be bio-based products. Think mycelium. It's going to be a really interesting and engaging webinar, so make sure you come along to that one. Thanks everybody for joining us today. Derek, massive thank you for coming on board and chatting with us. And let's keep the conversation going, because I think what you guys are doing out there is amazing.
Thanks, Hamish.
Awesome. Thanks everybody. We'll catch you next time.